So this session is related to exercise 2 of measuring the mass, weight and density. In the last session we discussed exercise 1 from this topic. Today exercise 2. Uh, Structure question 1. Figure 3.1 shows an oil tank that has a rectangular base with a dimension 2.4 by 1.5. So length and width are given. The tank is filled with oil having a density of 850. The depth is 1.5. So this height or depth is 1.5. Calculate the mass of oil in the tank. So how we relate density with mass and volume? Density is mass divided by volume. So if we need the mass, it will be density multiplied by volume. Density is already given 850 kilogram per meter cube. We need the volume. How to get the volume of a cube? Like, because the liquid is inside the box, so the volume of this box, if the liquid is completely fill up this box, then the volume of a box will be equal to volume of this liquid. But they mention the height of the liquid, so how we can work out, because liquid take the shape of the container. So volume of the liquid inside will be 2.4 length multiplied by width multiplied by height. So what is the answer when you multiply 2.4 with 1.5 with 1.5? That's 5.4. So the volume will get 5.4 and the unit will be meter cube because lengths are in meter, so the volume will be meter cube. Now to get the mass, it's density multiplied by volume. The density is 850 multiplied by 5.4. What's the final answer when you multiply 850 multiplied by 5.4? 4,590 kilogram. Sometime in marking scheme, they might round off. Like they might write this as 4,600 kilogram. But don't bother about that, because in marking scheme, most of the answers are rounded off. But you don't have to bother about that. Your answer should have minimum 3 significant figure. So 4,590 is the right answer. But when you check the marking scheme, maybe, I don't know, maybe if they write 4,600 for this, so that is also acceptable, because in the marking scheme, most of the answers are rounded off. The next part, when he is checking the level of the oil in the tank, a man drops a brass key into the oil and it sink into a bottom. So what happened? We have a container which is filled with the oil. A man drops, by mistake, he drops a key into the oil and the key sink to the bottom. What we can say about the density of the brass compared to oil? Because it is dropped in the oil. So what we can say about the density of the brass? Is it more than the oil or less than the oil? The key sink. If it is sink, it means the density of the brass key or density of the key is more than density of oil. Then explain how the key attached to a piece of wood could prevent it from sinking. So when we attach, yeah, that's the right answer, that it is more. Now they're saying we take a piece of wood and then we place a key. On this piece of wood, we place this key and now it start to float. So the combined density of the brass, explain how attaching the key to a piece of wood would prevent the key from sinking. So why the key will not sink now? Because the combined density of wood and key is less than oil. That is why it will float. Yeah, so because the combined density of a wood is less than wood and key is less than the density of the oil, that's why it will float. Same thing happened like these life jackets which are used in case of emergency. So what happens, these life, when you are wearing these life jackets, you don't you will float on the surface of the water. What is the reason for that? Because the combined density of the body and the life jacket is less than the density of the water. That's why the person will float. Yes, you can mention that wood will float, so it will prevent it the key from to sink. That's also a right acceptable. You can also mention wood would float on the water and attaching a key wouldn't sink. That's also correct answer. In question 2, figure shows a remote sensing equipment. Remote sensing equipment are equipment used to monitor from far object. Yeah, that's also good, Yusra, that density of a wood is low. That's why the logs float on the water. That's true. So the mass of the equipment is 350 and the acceleration of a free fall, the gravity is also known as the acceleration of a free fall, that is 7.5. So gravity is 7.5 and the mass is 350. What is meant by the term weight? So first they're asking the definition of a weight. So how we define the weight or definition of a weight? Weight is basically a force or a pull of gravity. So pull of a gravity or force of a gravity is known as the weight. The force exerted on the object due to a gravity, that's also right, Abdullah. Then calculate the weight of the equipment. How we calculate the weight of equipment? Weight is mass multiplied by gravity. So mass of equipment is 350 and the gravity is 7.5. So what is the weight on the planet? The weight of this equipment on the planet? 350 multiplied by 7.5. So it will come out 2000. 350 multiplied by 7.5. Yeah, what's the answer? So 2600 Newton. Rounded off value will be 2600. Exact value 2625. So in exam you will write your exact value 2625 newtons. Because it's a force, the unit of the force is Newton. If it was density, then it will be kilogram per meter cube. But because weight is a force and the unit of the force is Newton, that's why we are writing N. The next part, the equipment releases a balloon from a point, a small distance above the surface, the atmosphere. at the surface of a planet has a density. So the density of the surrounding air or the atmosphere is 0.35, and they release a balloon which is having a mass of 80 gram and the volume is 0.3 meter cube. We have to find whether this balloon will rise or sink. So to identify whether it will float or sink, we should find the density. If the density of the balloon is more than the atmosphere, it will sink. If the density of the balloon is less than the atmosphere, then it will float. But as you can see, the mass here is given in gram and the volume is in meter cube. And the density of the atmosphere is kilogram per meter cube. So the mass of the balloon should be in kilogram as well. So it is 80 gram. We'll convert the mass of the balloon in kilogram. So converting gram into kilogram, we'll divide by 1000. So it will come out as 0.08. To get the density of the balloon, mass divided by volume, so 0.08 divided by the volume of the balloon is 0.3. What's the answer? 0.08 divided by 0.3. 0.26. So the density of the balloon, when we calculate the density of the balloon, that is coming out as 0.26 kilogram per meter cube. So if the density of the balloon, which is 0.26, and the density of the surrounding is higher, 0.35, so this balloon will float. So predict what will happen. It will float. And reason, explanation, you will mention that the density of the balloon is less than density of atmosphere, that's why it will float. Then another question, question 3. A block of wood has a volume of 210 centimeter cube and having a mass of 180 gram. Calculate the density. So density is mass present in a unit volume, mass divided by volume. Mass is 180 and volume is 210. What is the density of this block of wood? Zero 0.857 gram per centimeter cube. Then this block is held above the surface of a liquid. So the density, like there's a liquid, and this liquid is having a density of 0.88 gram per centimeter cube. And we release the block here which is having a density of 0.857 gram per centimeter cube. What will happen? The block will float or sink. So as you can see, the density of the block is less than the density of the fluid, or when you compare the density of a wood, the block of wood is 0.857. This is a block which is having a density of 0.857, and the density in which we put the liquid in which we put the density of the liquid is 0.88. So liquid density is more than the block density. That's why the block will float. So where predict and explain what happened when the block is released. So when this block is released, this block will float. And why it will float? Because the density of this block is less than the density of the fluid. It will sink or it will float. You have a block. When you compare the density, look, you have a container, and a container is filled with a liquid. The density of the liquid is 0.88. This is the density of the liquid, gram per centimeter cube. And you have a block which is having a density of 0.85 or 0.86 gram per centimeter cube. So because the density of this block is less than the density of a fluid or a liquid, that's why it will float. The last question of this exercise: a rectangular container has a base with a dimension of 0.12 and 0.16. The container is filled with a liquid. The mass of the liquid is 4.8 kilogram. What is the weight of the liquid in the container? So weight is mass multiplied by gravity. So mass is 4.8, and because they did not specify the planet, so you will always consider as 10. So multiply by 10, you will get 48 Newton. As the unit of the weight is Newton, not kilogram per meter cube. Kilogram per meter cube is a unit of density. The depth of a liquid in a container is 0.32. Calculate the density. So how to calculate the density? Density is mass divided by volume. So we have the mass 4.8. And what about the volume? The dimension, it's a rectangle. So length, width and height, we multiply them. So it will be 0.12 multiplied by 0.16 multiplied by 0.32. So 4.8 divided by the product of 0.12 into 0.16 into 0.32. What is the final answer for the density? The volume is 0. Okay, when you solve for alone for volume, that is 0.006. So what's the final answer for the density? Check your answer again. 4.8. It cannot be a very small value because it is 4.8 divided by 0.006. So numerator is bigger, so it should be in whole number, a bigger number. So it is 781 kilogram per meter cube. Is it clear? This exercise. So this was exercise related to measuring mass, weight and density, the exercise 2.